two as we get set up. We'll be joined by JeanCarlo Bonilla, who's the Director of Insights and Impact at DataKind. And so DataKind is basically the title of the presentation here is Using Data Science for Social Good. So I won't give it away. JeanCarlo will explain more about what's going on. And we're going to run this now for, he's going to speak for 25, 30 minutes. We'll have time for 10 or 15 minutes questions at the end. And then just a reminder, there will be a reception at 6 o'clock just outside. So please stick around for the keynote, stick around for the reception afterwards. JeanCarlo, you close to good?
Run this. Give me 2 seconds.
We good?
Seems so.
Okay.
Yeah, hang on, I'm just trying, I don't know why it's not connecting. Guest. Oh, no, that's why. It connected to something else. Yeah, there you go. Yeah. Thank you. Good call.
Okay, thanks everyone for your patience. JeanCarlo, thanks very much. Welcome, and look forward to hearing you talk. Thank you.
Thank you, thank you. Is that me or? All right. Hello, everyone. I am in between a very interesting conversation about, biosensing, past thoughts and drinks. So I know it's going to be a tough challenge. I'm JC, and I oversee programs and projects at DataKind, and it's just a delight to be here with you all today. And I have a task to try to give you a different perspective, and I think that it's been fascinating to see this trajectory of looking at data science in a strategic point of view, what Jürgen presented, and now this last thread from John and Lane, very interesting on biosensing. So what I'd like to do, it's at the intersection between, my equipment is not working today. Let's see if this works. All right, we'll go from here. I started the day today in New York, and at 5 in the morning, I get my alarm. So yeah, I don't have this kind of chirp. It's kind of hippie and zen, like birds and things like that. As you can imagine, after that, I'm having an issue with this laptop. I don't know what's going on. It's not going through nor. Let me just. Give me 1 second. I'm going to switch to, I think is I have it somewhere else. Give me 1 second, because otherwise it's going to be a long conversation with a lot of technical difficulties. Let's see if this works. All right. So, hi everyone, I'm JC Bonilla, and I just came from New York. I'm super excited to be here, and I got up at 5 in the morning, followed by an Uber ride. And the Uber ride, you know, does what it does. It gives me the most optimal distance from me from home and the airport. I check in, and after that, I take about 6 hours of a flight where, you know, it becomes very productive. I go online and I have 6 hours on continuous work. I did not get pulled out by my legs or any devices documented the exchange between me and security. And nevertheless, we land, another Uber ride, and then I'm welcomed at the hotel. And Dr. Bonilla, you know, welcome, you know, this is your hotel, whatever, and then this is your newspaper for the morning, right? About 90% of what I said is true. And that's basically the perspectives that we have today. These digital information flows are very interesting. And wherever we are, whether it's thinking or intentional or hacked, this information is available for grabs. And throughout today and tomorrow, I love for you to start thinking about data from a different point of view. Maybe you're thinking from the point of view of, I don't know, how well did I sleep? So that's, you know, sleeping alarm type of thing that I use in the morning that works well. Maybe you're looking at it from the point of view of transportation. Which one is the most optimal point of view from distance from point A to point B, given the traffic conditions there? Or perhaps you're interested in, you know, customer insight, so you can customize an experience, right, and deploy what hospitality is interested in. So what I found is in this work that we do, there's always about 3 or 4 perspectives in how do you look at data. Number one is the aspect of we're trying to erode the divide between human and machine, right? And then there's all these great guys like you who are the intersection between cognitive computing and artificial intelligence, and that's what you're going for. And that's awesome. You know, these type of applications are actually predictive in nature, and they help me, you know, I don't have to think, and actually anticipates what I want. Amazing. More power to these apps. Or perhaps you're one of these that is always interested on what is the state of the art of the possible, as you're going to mention, right? So where can I apply a neural net, you know, deep learning and whatnot. So this type of what is the hottest and coolest technology or model out there, and how can I learn it, and how can I build it or deploy it? Or perhaps you're interested in modeling very tricky things, right? In this case, swipe left or swipe right is the aspect of happiness, right? With, you know, happy ever after for 10 years, or I don't know, or 24 hours. You know, we don't judge in these environments. Or perhaps you're that type of individual who is looking to find the item, the hottest thing which you have in everyone's closet, and position it that is a probabilistic measurement of success based on who I am as a client, okay? So I usually find that there is a kind of divide of where do we fit in all this type of work. And this is where then I take a turn. What you're seeing is in this kind of presentations that we've been seeing is we're starting to see data as a strategic asset. And the organization, corporate America, has been amazingly good at it. Mining data and kind of trying to decode or extract customer insight and bring it into efficiency, right? What I call data science for bottom line. It's very, very interesting, and I benefit from it. It wakes me up in the morning, it takes me to the airport, it gives me, you know, Wi-Fi while travel, and it tells me what kind of newspaper I want to read. Most of you, I assume, after these awesome programs and your careers, are going to end up doing this or already doing this. And this is what is fueling the emergence or the promise of data science, right? Very, very interesting data strategy and data management and data proliferation practices. Very, very interesting ways to mine data. And of course, very, really interesting ways to diffuse that insight. Yes? Everyone with me? Raise your hand if we're doing data science for bottom line. That means you're working for, you know, a for-profit company or something like that. There's nothing wrong with that, by the way. Awesome. But this is the issue. That just walk out the street, and the world is still tough, right? So this just is not across the street, but it kind of looked outside my hotel a little bit. Yeah, We are right now struggling with opioid and a lot of drugs abuse, and it's taking over our youth. And what we see in our families, whether it's child well-being or domestic violence, is very, very, very tough. So why is it that we cannot just decode love the way we do it in a swipe left and swipe right and bring it to child well-being? What's the problem that I cannot really predict who is going to be the next addict so that I can create an intervention early on, but I can predict what kind of sleeping device you're going to be interested in, right? Why is it that I'm not able to, I'm able to detect your face, but I'm able to detect who is hungry so I can actually give them a meal versus someone who's actually not in need of that meal? And that is really the divide that is taken today. And that is what we are saying as data science for social good. It's a divide that it's very interesting. On one side, we have corporate America that is doing things really, really well. And the promise of data science is paying off. Artificial intelligence, machine learning is doing very interesting things. Just look at the prior presentation. My thoughts may be unlocking a password very, very, very near. I wonder if it thinks with an accent, by the way. On the other side, what we have is the social sector, where human suffering, it is where it was yesterday, a year ago, 10 years ago, even a century ago. Education, poverty, civil rights, you name it. All these issues are real. And the divide continues to augment. So, okay, I got it. So let's just figure out the same methodologies, the same curriculum that you're actually learning here, or the awesome things that you're doing at work. Why can't we bring them into the social sector? And this is one of the reasons why we can do it. If you're familiar with this piece, this is actually a really interesting work from ProPublica that is called machine bias. What you see in this visual is a probabilistic score that gives a probability of crime for someone who is eligible for parole. So in this case, Vernon and Brisha, they both are eligible for parole. And Vernon has a more extensive record versus Brisha. But what you can see is that Brisha's probabilistic score for crime recurrence is way, way higher. The math is awesome. The model works. Any idea what the problem may be? I'm sorry? Yes. This idea of a statistical bias that gets diffused to the modeling, right? What we have here is the classical problem of profiling, where some of my cousins or people with different ethnicities have been targeted, and that data collection is triple or quadrupled what you see in other demographics, and as such, that modeling and that statistical bias diffuses throughout. So without the right context and understand the right digital flow, sometimes this work could be very, very, very tricky. So this is the work that we do at DataKind. We specialize in bringing data science in service of humanity, and we've been around for about 5 years. And what I'd like to show you today is a little bit of showcases of the intersection between data science, the way you maybe do it in your awesome company, so the ones that are going to hire you, and the social sector. And I like to, similar to Jürgen, I like to end up with 3 important milestones. We can do a whole day of things that we learned, but in this case, 3 is an easy number to end up with, right? So let me showcase a little bit of the work so you can get a flavor. This work, we did it with the Bill and Melinda Gates Foundation. A really interesting problem that is happening in Ethiopia. These are agrarian societies, right? I don't know, 80–50% of the economy is based on agricultural products. When you have wheat, right, and if a disease actually takes over that wheat, in this case called yellow rust, it can wipe down an entire crop. And these diseases actually spread with wind. When you detect yellow rust, you have 6 weeks to make an intervention. As you can imagine, the way you detect yellow wheat is by actually having a field inspector going into some wheat and looking at, there's yellow, that's an actual disease, and then let's apply some chemicals. And if you don't do that in 6 months, your entire crop may be at jeopardy. Very, very manual, and just not a few years ago, about 20% of the crop was just wiped out with severe work. So some of the work that we do in this case is, for those of you interested in remote sensing, using satellite images, you can then start understanding and using very interesting techniques of farm boundaries. And then once you figure out that problem, you can then use the signature of vegetation to understand whether this is wheat or not. And then based on the signature of wheat, to understand whether this is infected wheat or not. And you can be doing this for any type of crop. In this case, you have a visual of our partnership with a digital, Planet Labs, and we are working at 5-meter resolution here. Another example has to do with water. And this work actually we did about a year ago, and it's some hours south of you guys, the multilingual water district. A really interesting problem that's happened in southern California. Of course, it does not happen here, so you guys can be exempt. But with the problem with the drought, you have two systems. You have a system of potable drinking water and a system of recycled water, for pools, gardens, and things like that. So when one system is dry, you have to balance it with the other system. And what these organizations struggle with is that the modeling is based on populations and census data that is probably not that precise. And the idea of a consumption, it's non-existent. So using about 2 years worth of micro zone data, we're actually able to predict a seasonality study that gives them the predictability of when people are going to be using water for, I don't know, pools, golf courts, and whatnot, and systems can be balanced accordingly. Specifically, the problem that we have here is how much storage should they design, because in severe drought months or in the summer, these problems are really, really intense. This type of work is actually saving the utility about $5 million. Another type of work that we do, in this case, this is the American Red Cross. Very, very interesting problem that is happening in certain parts of the country where you have peaks of temperature. All of a sudden it's really hot and the temperature drops at night. Or it's a zone that is usually mild temperatures, and then you have 2 or 3 nights where it's super, super cold. The way this gets solved is that families many times put in electric heaters on their blankets. As you can imagine, an electric heater under a blanket may create an incident. And many families were actually dying or severely hurt. So in this case, what we did with them, by looking at historical data on fires and joining it with building records, we give them a predictable type of algorithm that allows them to target the areas where there's a high probability of risk in these homes. In this case, the technique of kind of just sending brochures or flyers is no longer used, and they were moving into targeted and control preventive type of work. The last example, just to give you a color of what we do, it's somewhat contemporary, this idea of hate speech in the form of cyberbullying. If you come and you say, you know what, these guys from Costa Rica with an accent, and they're bold, they know nothing. They get up on the stage, you start saying these things about me. Maybe, Anno comes and say, you know what, this guy, yeah, he's bold and whatever, but he's not that bad, right? So she comes and defends me, and because of that, maybe James says, you know what, JC is not that bad. So James changes his perspective, as if he's attacked me. This exchange is something that researchers have found that is called a golden counter speech. Someone says something that is bullying, the community or whomever reacts, and then the person changes his or her position. And it's a phenomenon, it's a hypothesis that Twitter and the Dangerous Speech Project were very interested in. So we created is an algorithm that is picking up patterns of golden counter speech. So it's an NLP type of project. As you can imagine, what this requires, it's a lot of manual tagging. So you get a whole corpus of Twitter feeds, and then you manually tag this thing, you create your classifier, and then creates a corpus that researchers now are able to come and investigate. These are my predictive features, and then create some type of policies for social media organizations and whatnot that may foster safe speech and then reduction of bigotry and things of that form. Okay? So, if I've done my job in the past 10 minutes or so, hopefully I piqued your interest. Look, that's interesting. I did not know I could use my skills, my superpowers, if you will, in the reduction of human suffering. And if I've done my job well, actually, and if you understand what we do at DataKind, I would love for you to come and do it at your workplace, and then raise your hand and volunteer, because all this work is done through a skill volunteerism. That means that we love for you to come and do it at Google and Facebook, all these companies have been mentioned, figure out what works and doesn't work, screw up there, and then come and bring your skills into the social sector. Yes? So I've done my job, right? So that's the first part. So what I'd like to do now is, in doing about 200 projects, we've learned a couple things that are really important in how you deploy data science in the service of humanity, or when your data science probably is not going to be at scale. And I think something that Jürgen was saying, I really reacted to, is this idea of how do you fail fast, and how can you become tactical when data science is all you got, and you have an organization that is basically in data maturity over here, and also you're going to take them to the data science realm. Okay? So let me give you 3 things that I see that are common aspects in the work. The first thing I want to say is that, look, I'm not going to undermine who we are. We're a bunch of data nerds, right? And we love our data, and it's fun. Look, you come and you work with us, or you jump sometimes into projects because, man, that data is sexy, right? Or you just want to hack your way through that R package, or this new Python thing. It is cool, and I wouldn't be surprised that many of you guys have this clock in your offices, right? I wouldn't be surprised in some of you guys it's actually tattooed on your chest, but I'm not going to judge again, right? But what is the issue here is that many of these data projects, and we see this over and over and over, is just give me the data. I got it. I don't mind spending a week and just mining data and hacking my way through a data problem, right? This is an actual problem statement that I received from a considerably large, sophisticated non-for-profit. I want you to come and look at, community poverty, so poverty, and while you're at it, throw more data, and while you're at it, can you untoggle race and child abuse? What's the target variable here, right? What am I fixing, right? I mean, poverty, I don't know how many of you guys are economists. Maybe you can help me out. Are we talking about poverty at one level, below medium, below average? What are we talking about? And this is the reality that you see in the social sector, and the reality is actually that you see in many organizations. The reason why Silicon Valley data science, or data science Silicon Valley, I've got the name probably in reverse order, they exist is because structuring data problems is very, very tough. And many of you who are working with data today, you work with the data and you do data stuff, but taking the step back and what is the research question? What is the scope of this project? It's very, 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 very tough. Does anyone know what I'm talking about? Yes? Hi, amen for scoping, right? So, first point that I'd like to bring home is the idea of problem discovery and data discovery. At DataKind, we believe that we never start with the data. We actually start with the problem. Specifically, we're trying to understand what is it an organization is not able to accomplish today. So this type of questions. What's stopping you from doing what you want to do today? What do you want to be doing more of? And if you had unlimited resources, what can you do? Let me give you an example. And by the way, this premise, as simple as it sounds for all of us in the ML, AI type of work, is a really interesting shift from descriptive type of data questions to predictive type of data questions. Let me give you an example. The Numerical Campaign. It's a really interesting movement for some of us who actually have taken this country as our second country or have been naturalized citizens. This organization specializes in bringing green card holders or legal immigrants into the path of naturalization. They believe that the democratic process will be enriched with different perspectives. So someone like me, who comes from Costa Rica with an accent and whatnot, I can come and vote, and my vote actually makes this country better. What's the issue? There's 9 million green card holders who are not going for green card for citizenship for many reasons. So they come to us and they say, you know what, we have this problem. There's all these legal immigrants and they're not doing this thing. That's the reason why we exist. So here's the question. Can you build me a database? Right? Right? And sure, but wait. We'll build a database, but what is it that you're trying to do? What's your pain point, right? What is it? And they say, well, the pain point that we have is that we just don't know where they are. These, where do they live, right? Because the way that they work is through workshops, right? And they come and they educate someone on the 20,000 things they can do that are free and whatnot to go from a green card to an actual citizenship. Okay, so if you're able to do that, what would you like to do more? Workshops. And one of the problems that we have is that sometimes we plan for 100 people and only 50 show up. Or sometimes I order 100 sandwiches and 200 people show up, and then half of them are not having that they had a great workshop. So these type of questions help us to understand this problem of predictability, right? And then by looking at historical data, now we're able to find where are the attributes of success and what are the infrastructure requirements in terms of demographics, distance to public transportation and whatnot. And then all of a sudden you create a propensity score that maps out spatially where all these different pockets in the country, where they're located, and distributed, and what time of the day, and what day in the week this type of workshops will take place. The problem with this, and this actually works, the only thing that you have to keep in mind is when you do this type of work, the shift between the descriptive to the predictive type of question. When you're grounding your question on what is it that you like to do more of, you help an organization asking the question that they want to have tomorrow, but you want to bring it today so they can be predictable and they can optimize resources. You bring an organization that it's in terms of data culture over here to over here in like 6 months. And the culture shift is very, very difficult. And sometimes these organizations, they just, they have a wonderful experience, but it's very, very, very difficult. Some of the problems that we were hearing that maybe you'll be struggling with in terms of, at scale corporate America are very different type of problems. This is the medium, small type of firm where you go from an access database to an actual predictive model that lives on, I don't know, AWS instance and is telling them how many, chairs they need to order for the workshops that is coming up a week from now. So keep this in mind, that the transition from intuition-driven management to data-driven management is tough, and organizations sometimes struggle with that. My second point actually goes to a little bit of history. If you could see here, that's Napoleon Bonaparte. And for those of you who follow data quotes, I like this kind of stuff. This quote is used a lot. That war is 90% information. And this quote actually is used to validate the importance of the work that we do, data work and preparing. If anything, this quote actually validates my first point. The idea of problem discovery and scoping is all about preparing, right? The reason why I like to use this quote is because it's 90%. The remaining 10%, oh my gosh. I mean, it's super tough to have a data project that always goes smooth. And then all of a sudden, project management, budget, team formation, just us being individuals and going crazy with each other. And all of a sudden you realize that a data project becomes just a project with human beings, and all of a sudden you start doing things that are outside data science. For those of you who do data work, right, the whole premise of I spend 80% of my time cleaning the data, right, and 20% mining the data. In this case, I spent all my time on the other remaining 10%, right? Which is, how are we producing these high impact projects? And sometimes it goes beyond the math. And this is something that I find that is very, very important in today's data science skill set. And in our prior talk, it was referred as the unicorn. Designing with and not for, it's very tricky. I did not go to school for child well-being or immigration reform. Those are things I do not understand. I understand math, I understand numbers, and I know how to do projects, right? So what makes me equipped to have high impact in these sectors? And I could argue that's the same thing for many of you. You know how to do statistical modeling, but what makes you an expert in marketing? And all of a sudden, because you know time series, how come you can do finance, or just from finance going to, I don't know, web analytics and whatnot, right? So the aspect of who you're designing with, it's really, really key. What this means is that we need to know how do we bring this subject matter expertise and the context into our data projects. And number two, it's a real invitation to come and co-design with us. What do I mean with this? Data sometimes is obscure, especially if you're talking about mental thoughts and things that we heard before. I mean, just think about it. When we were hearing, it's like, oh my gosh, the technique is very interesting, but it's it makes us feel a little bit uncomfortable, right? When you throw Rsquare and probabilistic measures and things like that, people usually feel that way. So a true invitation to come and co-design is something that requires a shift from IQ to EQ. In this case, I'm not talking about emotional intelligence. I'm talking about empathy. How many of you are familiar with the concept of T-shaped, the T-shaped professional? Yes? Something very interesting that the folks at IDEO and IBM use a lot. The idea of having, a deep technical skill, so your depth, there's depth, and a broad ability to come and communicate. And this is that individual, that's the unicorn, that actually comes and allows you to go between business requirements and technical requirements. Really, really interesting hybrid. You know what happens in data science for social good? It's not enough. Here is the pie-shaped individual. What this means is that you may be the NLP guy, right? And then you know your NLP or your, I don't know, classification or whatever it is, and you're able to comment and converse. You're able to translate. You're very good at throwing jokes. But can you do it in I don't know, marketing or in finance? That aspect of context is key. And yeah, sometimes we do the same things, but comment and co-designing, it's key. And in the absence of an individual who can do this, most likely you're going to have a pair. So design with, not for. And again, this idea of empathy is key, right? Because what we're looking at is when you see someone who you're talking and then also like you're talking at them and like it's going past them and you're talking about numbers and charts, slow down and understand where they're coming from, right? But what I can guarantee you is that when these conversations are enacted, that's when you start seeing high impact solutions coming about. My last point comes from the technology lifecycle. The idea that a product has a phase of losses, which is called sunk cost. And eventually, when sales pick up, right, my true profits will come in and be deployed. The way I look at this for the context that we do in data science for social good is dividing this chart in two parts. First one is the good old R&D. A lot of the work that actually got presented in a prior conversation, I'm really familiar with because in the work that I do in academia, there's so many struggles today in adoption of data science. There's too many models that are actually being built, and there's very few models that are actually being used. I think Jürgen presented that as the last mile. Corporate America and many of your organizations have the funds to actually afford that. You create 15 initiatives, maybe one sticks, right? About 5% of the revenues in America are used for R&D. In the technology sector, we're talking about 20 to 30% of revenues actually deployed in R&D. That means that you could create this whole data infrastructure, and if it works, it works. You can create 3 or 4 different models. If it works, it works. Maybe one of these initiatives actually has potential for impact, and that's the one that gets moved on into the second phase here. I'm a walker, so the whole thing without the clicker is killing me. So that's the second phase, right? The second phase is, now that I've gone through R&D, I'm actually launching a data solution. This is where it ain't about data, it ain't about technology. It's about us, right? I like it. I like the colors. The whole premise of technology acceptance is about perceived usability and perceived use of use. So all of a sudden, policy comes in, tells me you have to use this solution, so I use it. Or if I'm given 2 options between Mac and PC, I go with Mac because I don't know if all my friends do it, so I'm influenced by someone else. So all this stuff here, it's very, very difficult, because what it's telling us is adoption. It's not about how good my technology is at. It's about understanding the implications that you and I as human beings actually come and superimpose on our technologies. So what's the punchline? You have to go beyond Rsquare. That's what I tell my teams all the time. And it's building for predictability, right? That's the question. But then we have to look into adoption. So what does that mean in terms of data science? Number one is that high-impact solutions go beyond math. Just because you have the most predictive solution, just because your accuracy is, 90%, or your R-square is whatever, just because you have all the explained variance, that doesn't mean that your solution is going to be adopted. Actually, your solution is going to be adopted by something I call operationalizing your insight. This idea that you need to understand that a data solution is going to be adopted if the data flow matches with the frequency of reporting, if the process in which data and people come and converge actually matches, and if the people find that this is worth their time. And this is where actually user-centric approach is very, very useful. Something that we usually do not learn in engineering schools, so in STEM programs. And it allows us to come and operationalize insight. A classical example that I have is when you have a predictive model, and one of the features that makes your model from, let's say, 70% to 80%, so that elasticity of 10% in predictability, is actually drawing or making the organization do things that they're not comfortable doing, or things that it's not part of the digital information flow. So for example, I actually do have an example. Vision Zero is a project that we conducted for over a year, in which we're looking at traffic fatalities across 3 cities, New York, Seattle, and New Orleans. This is a really interesting problem, because if you're familiar with transportation, when you come and you take counts in a city, right, and maybe you've seen people taking counts of individuals, or you've seen ATRs, which take counts of a bus or a truck or a car. Grids, which is how most of cities are divided, avenues and streets, are kind of, symmetric in a way. And the counts are sparse. You have a count here, you have a count here, and you have a count there, because it's very expensive to have counts everywhere. So the first problem is, how do you create an exposure model that comes and diffuses these things, right? Why do you want to do that? So you can then normalize your sample, in this case have some volume of traffic counts, so you can take speed estimations and then have a probabilistic model for crashes. And that's how lives are being saved. So it was kind of researching nature. We first have to fix this problem, then we get into speed estimation, and now we can do crash probabilities. Well, our R-square was amazing, but all of a sudden, the way in which data is captured, right? It's seasonal. This is summer gigs, right? And when schools are in summer months, a lot of the Department of Transportation are actually not doing this work. And we were doing counts that for the summer were beautiful, right? So this is where we need to understand that by having this aspect of summer and no summer, our predictability went from like 70% to 30%. I mean, this is just basically, it's worse than random, right? But in this case, 30% of predictability was informing $9 million of infrastructure investment in Seattle. And they were very happy. So yes, we dropped from something that was highly predictable, where the data science was very interesting, but the use case, $9 million of investment on where to put traffic lights, where to paint, bicycle lines, and where do you put some protection, whether it's a tree or some type of pedestrian safe zones. Those type of things, right now we're being done with intuition, and a movement from intuition to 30% was so significant for this Department of Transportation. So this idea of go beyond your Rsquare and looking at how to operationalize results. So I leave you with my usual closing remarks that when we do this work, when we do this kind of presentation, sometimes it's the trade-off of I'm highly inspired or I'm highly depressed. So I don't know where you're going to be today. I'd love to see you in drinks and figure out where you're at, but usually that's what happens. You're aspirational or like, oh my gosh. But I'd like to leave you with something that we find very useful in the line of work that we do. And that's the punchline. We love this quote from Einstein that says that not everything can be counted, not everything that can be counted counts, and not everything that counts can be counted, right? And it's a really interesting challenge. But what we know is you become what you measure. And if all of a sudden you start looking for quality, and you measure quality, you become that. And in the sector that we're in, the challenges that we're seeing are tough. Education, hunger, poverty, you name it. But the moment we start looking at these problems from a quantitative angle, and we start looking at the techniques that have been validated and are doing different things, and you guys, thank you for doing that work, and that work is being lifted and we superimpose this on human suffering, we become what we measure. So thank you very much, and I look forward for any questions.
Okay, JeanCarlo, thank you very much for that. It sounds as if you'll be around afterwards as well to take any questions. Maybe time for just a couple here before we wrap up. Let's see if we've got gentlemen in the back there. Thank you.
So you've been talking about conquering problems or addressing problems like poverty and education and abuse. There's been lots of studies into these, and sometimes they disagree with each other, and some of them get airtime and some of them don't for political or biased reasons. Is a solution really better data science, or are we looking at a social issue to where even if we had the absolute answers to these, they couldn't get out and no one would want them because, I don't know, maybe they're offensive to somebody, or they clash with a political agenda or a business a business motivation.
I hear you loud and clear, and you're asking a question that is a two-part answer. Number one is we shouldn't be fixing poverty. That's the function of the government, if you want to think about the government holistically. But in the social sector, a lot of the delivery is to come and do things where the government is falling short. So let's say education, right? So everyone should have a great education, but also, these neighborhoods, they don't have it. So you see a foundation, a community comes and actually tries to solve that issue. So that's one problem, and I don't know how to address that. And that is political, that is not data science. Where the sector has decided to make a difference for whatever reasons, this is where I see data science making a difference or having an opportunity. And we need to be honest that data science does not fix education. What data science does, it would amplify an organization, amplify its mandate, so they become more efficient and better at what they do. And this is a little bit to the idea of the pie-shaped model. Look, we don't cure cancer, but we would like cancer to be cured. So our jobs in data science is to make sure that these organizations that are in intersection between cancer or whatever they're into, right? We're tool them, and we give them techniques using their data and things like that, so they become better, more efficient organizations. So data science amplifying a mandate in one of these organizations.
Okay, it's a great message to finish up on. JeanCarlo, thank you very much. Thanks to all the speakers this afternoon. Really appreciate it.